This lesson is Properties and Methods of Numeric Data Types. The objectives for this lesson are to understand the properties and methods on numeric data types, working with integer values, decimal constants, and the methods for working with decimal values. We then take a look at working effectively with date and time data types. We'll learn how to extract date or time data, perform date arithmetic, how to format dates and times, create a date-only value and extract that date information, and create a time-only value and extract time information. Each of the numeric data types are structures, and those structures contain certain constants and methods that you'll find in common. So they'll have things like min value and max value. They each define their own minimum value and their maximum value. They also have common methods such as equals, parse, and TryParse. We're going to take a look at each of these in some of the different data types. So let's start out with the integer constants and methods. The int data type has a min value. It also has a max value. Let's take a look at what each of those comes out to be. So if we take a look at these, it's the minus, like 2 billion, whatever, and to a positive 2 billion and whatever. So this is constants that are built into these structures. And we can do the same thing for decimals and all the other ones. And we'll take a look at those in just a minute. Next, let's take a look at some of the methods that are available to the int data type. Let's try the equals method. Int ID equals 1. And then on line 3, we do int.Equals. And we're going to compare these two parameters that get passed in. One is the ID variable, and the other one is a 1. And that is exactly the same as writing ID equal 1. So if we run this, we end up getting a true and a true. The next method is the parse method. If you pass it some sort of valid value, like a string, it will attempt to parse that into an integer. So here I have a valid string 10. And if I run this, it gives me back the numeric 10. So I could assign that equal to some value. So int ID equals int equals parse. And if I print that out, but you'll see that this will indeed work. So it does convert it from a string to an integer. Now, if this is an incorrect string, for example, you put a non-numeric value in that string, it's going to have problems. And it's going to tell us that in the debugger. Execution will stop on the line that's the offending line, and it'll tell us that the input string was not in a correct format. And the final method here is TryParse. This one will not raise an error. It will simply return a true or false based on whether or not it could make the conversion. If it can make the conversion, it will put it into the output variable that we pass in as the second parameter. So here I've done the same two samples that I did in the previous version. I've done a 10 and a 10a as strings, and we'll see the results when we print these out. So we get a true for the first one, and we get a false for the second one because 10a cannot be converted into a valid integer. And then temp1 becomes 10, and temp2 becomes 0, because again, that's the default value for an integer. If you don't care about getting the output variable, you don't need to declare a variable. You can simply use out underscore. It'll throw away the value, and now you can just test to see if that value can be converted to an integer, and it'll return the true or the false, as it did the last time. Now, the decimal data type has all of the same constants and methods as the int data type that we just looked at, plus it adds on a few additional ones as well. So let's take a look at the min value, the max value. We'll go ahead and run this, and we can see this incredibly large number there. Not something that you're typically going to use that much, but if you need it, it is there. And it has, of course, the equals, the parse, and the TryParse as well. But then it has some additional constants that we can take advantage of. And these are 0, 1, -1. So these are constants that are built in that will simply give you back decimal.0, decimal.1, and decimal.-1. Let's take a look at some of the methods that are unique to the decimal data type. Var result equals decimal.Negate. And we're going to negate some operand there, in this case 10. So when we run this, it does exactly what you would think. It'll give us the negative of that. The next thing we'll look at is the ceiling method. And how about we do something like 10.3m? So what ceiling does, if we take a look, it actually rounds up to the next highest integer up. If we do then the floor method, it will round down, as you'd expect. And then, of course, there is simply round. So if we do a 10.3, it's going to round to the nearest whole number. If we do a 10.9, it's going to round to the nearest whole number. There's also one last one, and that is called truncate. And truncate does exactly what you would think it does. It simply truncates off the decimal portion of that decimal value. I'm not going to go through all the other numeric data types. Looking at int and decimal, you'll get a pretty good feel for what happens with integer type or whole number type data types versus those floating point data types. They all have the same constants, the same methods that we talked about, and then they might add on some additional constants and methods just depending on what is needed for that particular data type. So you can look those up yourself in the Microsoft documentation online.